In Yazd, Iran, summer temperatures regularly cross 40 degrees C, and parts of the Arabian Peninsula have recorded over 50 degrees C. Yet homes there stayed cool for 3,000 years without a single watt of electricity. No air conditioner, no fan, no compressor. Just towers, screens, and tunnels built from mud, brick, and wood. Some of these buildings measured 20 to 23 degrees C inside during peak summer heat, while the streets outside were an oven. That's not a myth or an exaggeration. It's documented in architectural and environmental engineering research, comparing traditional windcatcher buildings to modern ones. And the wildest part is this. The exact system that made this possible is now essentially illegal to build in most of the United States. Not banned in name, but blocked through a tangle of fire codes, energy codes, and HOA rules that never existed in ancient Persia. By the end of this video, you'll understand 3 ancient technologies that beat modern air conditioning at its own game, and the real reason America walked away from all of them. Let's start with the tower that started it all, the Badger. The Badger, or Windcatcher, is a tall structure that rises above the roofline, built specifically to catch prevailing wind and pull it down into the building below. The earliest depictions of this idea come from ancient Egypt, roughly 3,300 years ago, where homes near the Nile show angled scoops on the roof designed to funnel the north wind indoors. In Persia, the design was refined for centuries, and Yazd became so famous for its windcatchers that it's still called the city of windcatchers today, with hundreds of towers still standing. Here's the actual physics behind it, and it's simpler than you'd think. Wind hitting the tower creates high pressure on one side and low pressure on the other. The same principle that lifts an aircraft wing off a runway. That pressure difference actively pulls hot air out of the building and pulls fresh air in. It's not passive luck. It's engineered airflow. Many windcatchers had 4 or more openings facing different directions. So no matter which way the wind blew, one side pulled air in while the other exhausted it out. Even on a still day with zero wind, the sun heated the top of the tower, warming the air inside and making it rise, dragging cooler air up from below through basic convection. Research on windcatcher-equipped buildings found they could lower indoor temperatures by 10 to 15 degrees C compared to outdoor peak heat. Picture this, a 45 degrees C day outside, and the room inside sitting at a comfortable 30 degrees C, with nothing running, nothing plugged in, no electricity bill. But the Windcatcher wasn't working alone. It had a partner buried underground. That partner is the canat, and it might be the most underrated engineering feat in human history. A canat is an underground channel, carved through mountains and hillsides, designed to carry groundwater from higher elevations down into desert cities. Iran alone has over 37,000 of these channels, stretching a combined 400,000 kilometers, built over more than 2,500 years without a single modern machine. One canat in Ghanabad, in Khorasan province, is estimated to be 2,700 years old, and it's still supplying water today. In traditional homes, a canat was sometimes routed directly under the lowest floor of the building. As the windcatcher pulled hot air downward, that air passed near the cool, running water of the canat, picking up moisture and losing heat before it ever reached the living space. Wind power from the tower, plus evaporative cooling from underground water. That combination created a working air conditioning system with 0 moving parts and 0 electricity. Now picture the windows of these same buildings, covered in an intricate carved wooden screen. That's the mashrabiyah, and it's doing more work than it looks like. A mashrabiyah is a hand-carved wooden lattice, found across North Africa, the Middle East, and even in Mughal India, where it's called a jolly. It looks decorative, but its real job is thermal engineering. The gaps break direct sunlight into diffused, indirect light while blocking most of the sun's heat from entering. The thick wood also absorbs heat slowly through the day and releases it gradually, smoothing out the temperature swings inside the room. And because air moving through narrow gaps speeds up, a basic fluid dynamics effect called the Venturi effect, the breeze at the window actually feels stronger and cooler to the people inside. In coastal cities, mashrabiyahs were built to project outward from the wall, reaching further into open airflow, while also giving people inside privacy from the street. That's 3 interlocking systems, windcatcher, canat, mashrabiyah, all doing the job of a modern HVAC unit, 3,000 years before HVAC existed. There were more tricks layered on top of these, and they mattered just as much. Traditional Persian walls were often 60 to 90 centimeters thick, built from mud brick, which delayed heat penetration by 8 to 12 hours through something called thermal lag. That means the scorching noon sun wouldn't actually reach the inside of the wall until late evening, right when residents opened everything up to release it into the cool night air. Domed roofs reduced direct sun exposure, and interior courtyards with a central pool created their own microclimate, cooling the air through evaporation right at the heart of the home. So if all of this worked this well, why don't American buildings use any of it today? It's not one single ban. It's a stack of rules that quietly makes it almost impossible to build. The first wall is fire code, specifically standards like NFPA 90A, which govern ventilation systems in the United States. A windcatcher creates a direct vertical air channel from the roof straight into the building, and that's exactly what fire codes are designed to stop, because an open shaft like that can let fire and smoke travel rapidly between floors. Building that legally now requires fire dampers, rated fire barriers, and special engineering approval, turning a simple ancient tower into an expensive compliance project. The second wall is energy code. Standards like ASHRAE 90.1 and the IKE are built entirely around one assumption: that mechanical HVAC will handle your indoor climate. These codes push for airtight buildings that trap conditioned air inside, which is the exact opposite of what a windcatcher needs to function. An airtight house and a wind-powered cooling tower cannot coexist under the same design philosophy. One seals air in, the other pulls air through. The third wall is money, and it's a big one. The global air conditioning industry consumes about 20% of all electricity used in buildings worldwide, according to a 2020 International Energy Agency study. In the U.S. alone, the HVAC market is valued at over $17 billion a year, and that industry helps write the very standards that building codes are based on. The fourth wall is your own neighborhood. HOA rules in most suburban developments simply prohibit non-standard rooftop structures or projecting lattice screens, the exact features a windcatcher or mashrabia would need. So it's not that this technology failed. It's that it never got the chance to compete on equal terms with mechanical air conditioning in modern American construction. And here's proof it still works when someone actually tries. The Portcullis house in London has 14 bronze chimney-style windcatchers built right into its roof, actively cooling the building today. Masdar City in Abu Dhabi built a modern wind tower directly inspired by ancient Persian design into its central plaza, as part of a zero-carbon city project. Researchers at Oxford, Bath, and Nottingham have run fluid dynamics simulations on windcatcher designs and confirmed they can match or beat light air conditioning, with zero electricity and almost zero carbon footprint. So the real question isn't whether this technology works. The data already answers that. The real question is why a solution this effective, this old, and this proven keeps losing to code books written for a world that assumes electricity will always be cheap and endless. If ancient engineers in a desert with no machines could outcool a modern American HVAC system using wind and buried water, there's clearly more we've forgotten than we realize. If this kind of forgotten engineering interests you, there's another video on this channel breaking down a piece of ancient technology just like this one, and it goes even deeper. Go watch that one next.